Hi, I am Robson Will, a master student at LSCR at the Federal University of Santa Catarina, where I am supervised by Professor Leonardo and Professor Marina Hirota. I study the relationship between weather and incidence of cardiorespiratory disease, but today I show you the work intituled Analysis of the Performance of the WRF model in high latitude region of the southern hemisphere. We all know the severity of this disease, being the leading cause of death in the world. We also know that this disease are related to air pollution. In Brazil, the scenario is not different. We have a high incidence of this disease, and they end up generating high social and economic costs for the country. However, Brazil is country with continental dimensions, cut by the equator and the Tropic of Capricorn. Because of its great territorial extension, the regions of the country end up behaving differently about the incidence of cardiorespiratory disease. In these graphics, you see that of 5 regions of Brazil, the shoulder regions has higher cardiorespiratory morbidity. Your hypothesis is that this is related to weather conditions. Within the sulfur region, we have three states, one of which has excellent characteristics for the proposed study. They have a good human development index, relevant population diversity, and they mainly have extreme climatic conditions, being the area with the lowest temperatures in the country. However, when we decide to study the states of Santa Catarina, we faced a great lack of weather data in adequate resolution for the most cities, especially in the small ones. So, how could we investigate the relationship between mobility and meteorology without climate data? Therefore, we decided to adopt the work to model the meteorological factors in each of the cities for 11 years. However, to guarantee the best quality of the analysis, it is necessary to know which is the best WRF configuration to adopt. For this, research is carried out in the existing bibliography and the public agencies that work with the meteorological forecast and the state of Santa Catarina, thus having a starting point for carry out the desired tests. These are the chosen settings used in these tests. There are variations between the different configurations in the microphysics parameters and the boundary layer options. WSM, Thompson, and Morrison were used for microphysics. SM2 and YCU were used to boundary layer, result in 6 test configurations. The tests were made for data of 2018 and compared with field measured data for 3 different cities: Chapecó, which is in the west of the state, Lages, which is in mountain regions, and Florianópolis, which is an island and the west of states is the capital of the states. Both sets of data were compared concerning correlations, bias, RMSE, and ZPQ. From now, I will present the results we found for these simulations. For temperature, the results showed the correlations between 0.146 and 0.65, with bias below 1 Celsius degree. PQD showed a result of the less than 2 for cities of Chapecó and Florianópolis, and close for 2 the city de Lages. Look at the box plot graphics. We can see that the Earth tends to underestimate average temperature in the coldest months, April to September, and overestimate them in the hot months in Brazil, October to March. An analysis using scatterplot shows the data diagonally, and when analysis uses the lines of factor of 2, we see the most of the data fit this relation. As for relative humidity, the correlations are good only the city of Chapecó, where they were close to 0.59. For the cities of Lages and Florianópolis, these values were between 0.07 and 0.412. The bias is low for the cities of Chapecó and Lages. Only in the city of Florianópolis this appears being 4%. The PQD presents good results, being the less than 2 for cities of Chapecó and Lages, and close to for Florianópolis, although greater than 2. The box plots graphics show an important difference between cities. In Chapecó, WRF underestimates data in the hot months and overestimates in the cold months. For Lages, the WRF is overestimate every month, while in Florianópolis is the underestimate every month. Nevertheless, the analysis with a factor of 2 and the scatter plots show the adequacy of most of the data. The analysis of wind speed showed the worst results, with correlations between 0.13 and 0.38, and the bias that reached 15% of the maximum value. The D of Pico were over 2, between 2.4 and 2.7. The best results were for Florianópolis, where the bias was 0.6 meters per second and the correlation was greater. The analysis of the block spot shows that the values were usually underestimated. Contrary to other studies done regarding the wind and the state, the lower resolution used maybe have affected this analysis more serious other authors' analysis. And the scatter plot highlights the poor results mainly for Chapecó and Lages, where the factor of 2 shows a non-adequately of the most of the data. The results of atmospheric capacity are interesting. Two cities had high bias, Chapecó and Florianópolis, but the correlation results show a good fit for them. It stays at 0.73, while the city of Lages presents a correlation of 0.63. We believe then this bias is one and two different in altitude between the measurement point and the grid point used for comparison. The deep echo present above 2 for the cities, Florianópolis and Chapecó, and below 2 for Lages. Due to bias, the factor of 2 analysis ends up being impaired. However, it is possible to observe a good diagonal in the scatter plot, and analysis of the block spot shows a close variation in the three cities, even with the impaired analysis of bias. To analyze the relations between cardiorespiratory morbidity and various meteorological parameters, we had to define a configuration that, on average, the best meets all parameters. So, ranking is made, attribute a point to the simulation, then had the best result for each of the characteristic analysis. For example, bias or the best GP equal or the best correlation. Finally, we added the points to get the result. The sum of the percentage difference between the results also compared with the correlation the ranking. This percentage is the difference and the best result and the author's results for each of the parameters of the analysis, like bias or RMSN analysis. That way, we have the following best configuration. For the city of Florianopolis, configuration 6 presents the best results. For Lages and Chapecó, configuration 1 presents the best results by the ranking. The analysis of the percentage difference for each of the results, however, showed that configuration 1 and 6 for Chapecó show the same variation, and the 5 result is close. For Lages, configuration 5 is the lowest percentage variation, better than 1, with the results close to 6. Finally, it was chosen that two separate simulations will be carried out with different configurations and that better serve each of the regions. But it is important to emphasize that in ideal conditions to be use specific configurations for each of type of data. But due the computational work required and the long time required for the modeling, this is not a feasible reality. Another idea is run several rounds of different configurations and use the average of the results to ensure a better fit known as a set analysis. However, this would greatly increase computational work and the long time too. When emphasizes the results present here were made with a resolution of 15 for 15 kilometers, but the final data will be made with a high resolution of 343, and we hope to achieve better results, especially for wind speed. We hope these results can help other research, and especially in chauffeur hemisphere with the WRF. Thank you for watching, and I'm open for the questions in this session. And for more details, read the paper and publish it in the final of Congress. Thank you and goodbye.